Hello everybody, welcome to another Ask Wortell live stream. Tonight we'll be discussing Azure Sentinel yet again, but this time we'll be focusing on implementing Azure Sentinel in DevOps, on a DevOps approach, and we'll be talking about gathering threat intelligence with Honeypots. My name is Koos Goossens. I'm a cloud and security consultant at Wortell, and I have some guests with me here tonight, which I would like to introduce. Our first guest.
Good evening. My name is Pouyan. I'm a cloud automation and security consultant, and we're really happy to join the whole team from Wortell tonight at the Ask Wortell show.
Thanks for being here tonight with us, Pouyan. Next up.
I'm Lars from Blitterswijk. I work for 8 months at Wortell now, and I'm working on the Vdara Honey network, which I will be talking about.
I assume that I'm going to be next. So, hello, My name is Gijs van der Menen. I'm a computer science and engineering student. I've been working at Wortell for about 2 months now. I'm a security analyst. I'm also working together on the Vdara Honey network with Lars.
Thanks for joining us, guys. But last but not least.
Hi guys, I'm Maurice de Jong, and as always, you can send in questions during the Ask Wortell live stream. You can send your questions in right here on YouTube in the live chat box on the right side inside here, or you can send them in using hashtag AskWortell on Twitter. And to encourage everyone to take part of the conversation, we have a very nice prize today. At the end of the show, we will pick one of the questions as our winner. And that will be the winner of Microsoft Flight Simulator 2020 for Xbox or PC. So get the questions in, send those in, and get the conversation going. What do you think about the prize, Koos?
That's really some sweet giveaway, Maurice. Too bad I haven't sent in my own questions for tonight. Before we take off with our two main subjects for tonight, I'd like to talk a little bit about some news first. Microsoft just recently had their Ignite event. It was 2 weeks ago, from the 22nd to the 24th of September. They have this event yearly, but now it was the first time they had it all digital due to COVID-19 restrictions, obviously. And there were a few nice announcements there, and there are a few I want to highlight here tonight. I want to focus obviously on the security products mainly and keep it as short as possible. There are a few announcements which are interesting. First of all, the rebranding of a lot of ATP products. Again, some would say, because Microsoft did make some changes in the last couple of years already. For instance, the Windows Defender ATP got rebranded to Microsoft Defender ATP because Windows didn't make much sense anymore, since Defender ATP is also available for Linux, iOS, Mac OS, and Android. So that got renamed Microsoft Defender, but now it's called Microsoft Defender for Endpoint. So we see a lot of Microsoft Defender products, and now you have Microsoft Defender for Endpoint, which was formerly known as MDATP. The Azure ATP, which you run sensors on your local domain controllers, is now called Microsoft Defender for Identity, and Office 365 ATP is called Microsoft Defender for Office 365. And on the Azure side, you have some changes as well. Security Center is rebranded as Azure Defender, although I do think you still see some links to Security Center in the portal and in documentation, of course. It probably takes some time before everything gets adjusted. But the individual protection Azure Security Center offered have their own names now. So the protection of virtual machines is now called Azure Defender for servers. And you have Azure Defender for Kubernetes, for SQL, and so on and so on. So no more ATP products. Sentinel as a security product is still called Azure Sentinel. So tonight I won't be making much mistakes on the naming parts, I guess. And talking about Sentinel, there were a few new features as well. First of all, the UEBA, which stands for User Entity behavior analytics, which is a feature a lot of people were waiting for. In the Azure portal, in the interface, you now have a new blade which is called Entity Behavior. It lists a top 5 of your accounts and hosts with the most alerts. You can drill down to open a profile, and there's also provided workbooks by Microsoft. You can drill down to the profile of hosts and users, and you can see the most important anomalies of that user. And this is giving you an aggregated overview of multiple different data connectors which are active on Sentinel. So it helps you keeping track of those anomalies. Next up is the threat indicator management. It was already possible to connect your own threat intelligence to Azure Sentinel, but now they introduced a new, more like a graphical interface for it. So now you have better insight in what kind of indicators of compromise are actually coming in, and you can even add your own. So you can search through them, but you can add your own as well. So if you suspect, for instance, a rogue machine or maybe a malicious IP address in one of your hunting sessions, you can add those as an indicator of compromise yourself, and all your KQL queries, which leverage the threat intelligence resources, benefit from that. Watchlist is a new feature, highly requested. It makes it very easy to create simple lists that can be lists of known IP addresses, maybe trusted IP addresses, important assets for your company, important users. And before, if you wanted to create a list in which you compare your KQL results to, you had to go through a difficult process of uploading that list to an Azure storage account, sharing it with a SAS token to make it to generate a publicly acceptable URL, and then put that URL in your KQL queries to compare the results and with those lists you've created. So it's a very welcome addition that you now have the watch lists. You can create them from the Azure portal or through the APIs, and you can create your own lists, upload CSVs from there, and you can query the watch list from KQL as well. But it's much easier than before. And lastly, there were a lot of new data connectors, but I don't think that on itself is very big news, because Microsoft is continuously releasing new data connectors over the lifespan of Azure Sentinel now. There are 60 data connectors right now in Azure Sentinel, but one notably addition is the Teams connector. And the Teams connector is part of the Office 365 connector, so you have to drill down to the connector page and enable that checkbox for Teams to make sure that data comes in. And well, obviously that can be quite helpful, because you can now correlate data from Teams, like deletion or creation for channels or applications, and obviously Teams sign-ins. So that's a welcome addition. And something I would like to mention here is logstash. Microsoft created their own logstash output plugin, and I'm a big fan of logstash. It has proven to be a very valuable tool, because it's very easy to ingest your custom data in there. You can even filter and parse data on the way. And before, we had to rely on a community, on a plugin which was available from the community. And now Microsoft created their own plugin, which also acknowledges the fact that Microsoft thinks this is an important product as well. One thing I'd like to add is that if you want to move over to Microsoft's official plugin, because that's officially the only one that's supported now by Microsoft, keep in mind that you have to change your configuration files as well. As you see here in the screenshot, a lot of fields have different names, so be aware of that. So that was a short update on news regarding Azure Sentinel. And we can obviously fill a whole live stream regarding Ignite, but just wanted to keep it short for now. And let's move to our first main topic of the night. Pouyan, I saw you published a very great blog a few days ago about implementing and managing Azure Sentinel ninja style. I know you're a big fan of the country Japan, but can you please explain to us what's up with the ninjas?
Well, that's a good question. If I think about it, it's maybe related because it's the same way ordered and organized the Japan as country, and I really like that. And the whole idea with the blog was the same, also to show the idea behind the deployment, the structure in it, and the processes in the DevOps way of working. So yeah, I think somewhere it's related.
Cool. But you were actually mentioning a lot of Azure DevOps related tasks, and I saw you used a PowerShell module for that, AZ Sentinel. Can you tell me what it is and how? Because I know that you're the original author of it. Maybe you can explain to us how you came up with the idea to create a PowerShell module.
Yeah. So I think it's a little bit longer than a year ago when we published Azure Sentinel to the community. Azure Sentinel is actually the PowerShell module to manage and to deploy and manage your Azure Sentinel environment through the code, through a descriptive way of working, and so that you have one point of truth and that you can translate that to your output within Azure Portal itself. So that's and you can use Azure Sentinel to configure your analytic rules, your detection rules, your hunting rules. And last week we finally added the option to add some of the data connectors. It was a really long requested feature. So hopefully we can speed it up and implement more and more data sources now also in it.
And Microsoft has not yet released a PowerShell module for this, right?
No, as far as I know, they are happy with the current one. But one day they will probably release the official one.
Yeah, they did recently documented all the APIs for Azure Sentinel. I heard that you had a lot of reverse engineering to do a year ago when it was just released.
That's correct. We started from the scratch, from screening and reading the API calls that were sent to the Azure portal. It's good, and I love to see the list of new features that you also mentioned regarding Azure Sentinel. I love to see that the team is working really hard. For example, a couple of things like the Microsoft Teams option. I can remember that last month I needed to create a default data connector for it, and now it's onboarded. So the speed is great from the team. It's nice to see that.
Yeah, it's really great that you can automate your detection rules, because organizations might have multiple Sentinel workspaces as well, and all those detection rules reside in those individual workspaces. So having a PowerShell module is a great addition to sync up those workspaces, if you will. But how would somebody approach using AZ Sentinel correctly if they want to use the DevOps approach?
Well, exactly. The Azure Sentinel itself, it can be used for the deployment way, but as I described in my blog post that I released, is there's more than only the deployment part. So if you go back and see the DevOps processes, then and how Azure Sentinel fits in that process. That brings the total picture that we have one template for our rules, for example, and we can publish it or deploy it to multiple environments or even customers, depending on what your output is, because that doesn't matter anymore.
But are we required to use Azure DevOps for this then?
Well, Azure DevOps is definitely one of the good features. You can also use GitHub with GitHub Actions, of course. You can use any other tool. But Azure DevOps, I think it's one of the, from developers' side, it's a great product. It covers all the toolings and that you need for the whole process. I think it covers the first place where you configure your work items, where things start, and then you step off to where to store your changes, like the repository side, and then the deployment side, and that's of course the pipeline. So then you have one product that covers all the three stages that you need. But you can do the same, of course, with GitHub Actions also.
Yeah, you already mentioned your code repository. Maybe not everybody is well aware of how such a thing should work. Can you explain a little bit about that? Are the Azure Analytics rules in your Azure environment becoming part of code now then?
Yeah, so the idea behind Azure Sentinel in the first place was to implement a shift left process. That's a way of working how developers mostly work, where they and that means that you bring your changes in a descriptive way. You store those on a descriptive way so that you can test them and analyze them. And that's what we try to do with the template files, because if they are stored on one file, that means that's our point of truth, and we can do anything with that. And the repository is what we use to store that on top of it.
Yeah. Yeah, and a Git repository has a lot of other benefits, obviously, because now you have version control on your analytics rules, on your configuration for your Sentinel environment. So if somebody needs to go in and change a logic app or a KQL query from a detection rule or a hunting query, they have to go through the code repository, and then you can see who made which change on which particular moment, and you can even go back in time if you need to, right?
Exactly, Koos. That's I think the whole picture as you want as a cybersecurity organization to achieve finally, to know what initiated the change, who implemented the change, who approved the change, and who deployed it even, and when was it deployed, and that's what we try to cover in the whole DevOps way of working, and Azure Sentinel is part of that whole process.
Yeah, and what's your idea when it comes to having, because you already mentioned testing your code, so you want to go through a process, which in a code repository are called branches. You have several branches before you go to the production state. But does that mean you have to have multiple Sentinel instances as well then? Because normally a customer most of the time has one SIEM or one Sentinel instance. How should they deploy those branches to Sentinel then?
Yeah, I think that's different for each customer, of course. But I think if we take a look at the stages, for example, for the dev stage, that's the stage where we only want to see, is there an error? Does our code, our request generate somehow an error? And that's it. And the second stage is the staging, the release stage is where we want to see, okay, we actually want to run it in an acceptance environment, and that can be choose that it is the same environment. I can imagine that's easier because then you have the same data, but then you need to take in consideration the way you treat your incidents, for example, or your logic apps, etc. That you don't break. But I think preferably is to have a dev environment which you use only for your short deployments, staging where you have some kind of acceptance data, maybe a shorter period so that the billing stays acceptable, and you have your production environment, of course, where everything, the real,
Yeah, because you don't want people messing up a single line of code in your analytics rules overview that might mess up all your analytics rules and maybe disable all of them or remove all of them. But you have some security measures in place for that as well in Azure DevOps, for example, like branch policies. Do you have some advice on that? How people should set that up? Because for me personally, I see customers use Azure DevOps, but they're just committing in master all day long. So that's not a Ninja style way of working, right?
Yeah, exactly. Well, we have come up to a three-stage branching actually. So the master, or they call it these days main. I found out on GitHub. And then you have your release, and you have, of course, your development. Those contain all your main codes, but you have, of course, your branches where the engineer itself is working on. That contains only the changes that that person is working on, and we use the pull requests and policies to go through those phases and also test them. And if you like, I can maybe give a short demo on that part.
Yeah, sure. Because a pull request is when you merge the branches, right?
Yeah, sorry. Yeah, so actually the idea is, as an engineer, for example, I start with creating a new rule. I save that on the template file, but that branch that I'm working on, so that's actually a copy of the development, the release of the master branch. That branch that I'm working on contains only my changes. And when I want my changes to be migrated into, finally, hopefully, into production, so first what I need to do is I need to make a pull request where I actually request if somebody will import my changes into the development branch. And that pull request process is really important because it gives us also the opportunity to do some out-of-the-box testing and seeing, is our naming convention right, or is all the properties filled in that are required, for example. And you can make it as big as you want, of course.
You prepared a demo, right? Can you show us? Yeah,
sure. So we are here in Azure DevOps. We have, of course, our repository. I have here, you see that we are in the master branch. I will go to the branches first. What you see is we have here 3 branches. And for example, I have created on this development branch some policies where I say, okay, this pull, if somebody wants to merge his code to this branch, at least one person needs to review this. But keep in mind, it depends, the numbers here depends on the team that you're working with. For example, if you're working with a team of 3 people and you put there 3, that means, of course, it's going to take a little bit longer until your pull requests get merged. So take that in consideration. We have, of course, other tests. One of the things that we talked was the work item, the real agile way of working, of course. I have put it on optional for the purpose of the demo today. And one of the nice features that I really like is the build validation part, where you can say, okay, I have configured a pipeline, and that pipeline is some code, I can show that, that we want to trigger to test this automatically. So instead of relying completely on a user that reviews our changes, is also to rely on our code to test our code.
Oh, cool. So what are kinds of things you can test on? For instance, a detection rule, can it actually track if my KQL query is actually working, or is it more like a naming convention, or what kind of things are you actually checking?
Well, I think it can. We can include all what we want. We can deploy those rules to an environment and see if they generate an error. We can analyze them by seeing if all the properties are there. We can see maybe if an alert rule name needs to be to match a certain rule. So
lowercase or whatever, yeah.
Exactly. And in this demo, I am using Pester. Pester is a PowerShell testing framework. And because our rules are in JSON, that means when we convert them, we have PowerShell objects we get in return for them. So we can test them completely. So I will go shortly through this to just show some of the things that happen here. So what we do is we read in this case, our alert rules JSON file. We see first, okay, does it convert to a JSON file? Because I get lots of bugs on the GitHub repo for Azure Sentinel where people are having a hard time to fix the escape tracers, and that will create an error when you try to deploy it. So this is a great simple task to see, okay, does it convert to JSON at all? And here, for example, what we say is, well, we want for our alert rules to at least have these properties defined. Right?
Cool.
So it looks in it and it says, well, you need to at least, because of course, as you know, analytic rules has more properties, but those are not required properties. So this is a way that we can test that. And the same is for the fusion rules or for ML behavior analytic rules. So this is how we write our tests, our automatic tests. And for that, we have a simple pipeline, actually, where we run a PowerShell command where we say, okay, run this test and give me that for output.
Yeah.
And I will show that because
and when you run this pipeline, it's actually ran on an agent from Microsoft, right? Which executes that command for you and performs the deployment.
Yeah, exactly. That can be a Microsoft agent, but of course, I can imagine that some organizations prefer to use their own agents due to because they are working with security related products. So that's fine too. So I have here in my demo 1 branch, that's my branch, that's where I'm doing some working. And I have updated, not this one, sorry. So I have updated my for example, my alert rule and committed that, and that's now shared to Azure DevOps. And I want to merge that to the development branch. So I created a demo pull request where I say I want to merge my changes from demo 1 to the development environment. And as you can see, it already stops. It says, well, it's not going to happen because the build failed. And if we click on it, and we see, okay, this is actually the pipeline. And we can click here. We have the tab that's called tests. If we click on that, we see, okay, it tested 6 properties, but 1 was failed. And if we click on this one, we will see that it says, I expected to have those properties, but I get in return other properties that doesn't. So it wanted this,
so this
but it gets something
found. Yeah.
And it says, well, I wasn't able to find display name. And if I look here, I see, I made a typo, of course. And that's, and this is something very simple, but this happens a lot when you review a code change from another team member. These are the things that normally never pay attention to.
Yeah. But this pipeline, Pouyan, is deployed before colleagues have to approve for this pull request, right? Or
this
after?
pipeline is already there. It's already configured, and it is attached to the development branch policy. And that means that everybody, it doesn't matter from where, wants to merge something to the development branch, that pipeline needs to run and needs to succeed completely. Because one of the properties is that I said is when you are publishing those test results, fail if there is a failed task in the results. So to demonstrate short how it will be fixed, so if I change this and save it, and I say update it, and what's the nice thing about this is when I fix my issue and I say, well, okay, this is my fix, and I send it back to Azure DevOps, to the centralized repository.
Yeah.
second. Did I send it? Yeah. You will see that the build pipeline will get triggered again automatically.
Right. Yeah.
And it starts again testing and seeing what happened and that.
Nice. And now it succeeds, obviously, because you corrected the typo.
Hopefully. Or I made another typo.
Maybe we made a new one. Yeah, that happens to me as well. A lot of times.
The demo gods always surprise us.
Yeah.
So if we would go, because we see it's succeed, if we would go here, you will see, okay, that required check is passed now. Now it's able to merge into the at least development branch.
Yeah. Okay, so this is the build part of the code. So now your rules are in your Git repository, in your code repository. But how can we actually deploy those rules now to our Sentinel environment?
Yeah, so this part was really for validating. So when we take a look at the shift left process, well, as I said earlier, it is the CI and the CD process. So the testing and the deployment part, we want to do it as fast and as soon as possible. So this was the part where we test our changes as soon as possible because this is something you want to find out before you are deploying against your production environment, then get there. So when this process is done, the next will be, of course, okay, now we are going to deploy it. And for that, we use Azure DevOps pipelines. And Azure DevOps pipelines, they upgraded a while. It's, of course, now really great in YAML format. But in the past, we had something like build and release. And they include that into one, and they call it pipelines, like the same with GitHub Actions. And that's what we use to deploy our code. So, yes.
Yeah, I'm sorry, we have a bit of a delay here. Normally we would have this live stream in our studio in Gouda, but now everybody is at home, streaming from home, broadcasting from home. So we have a small delay. So having a real conversation is a bit tough sometimes, but that's okay. I wanted to ask if you can show something, how a deployment with a pipeline should look like. Yeah.
So in this case, we made the choice to make use of multi-stage pipelines. And the great feature that we get in return is that we can somehow implement the same what we did with the pull request, where we checked if somebody needs to approve things, policies on the same level, but on the deployment side. So, for example, you can imagine that when something gets merged to our development branch, maybe we don't want to have any checks on it. We just want to deploy it to the development environment and see what it returns. But when we go and we want to deploy it to the acceptance environment, then maybe we want that somebody reviews that and approves that change. And even if you go to the production, maybe we want that two people approve that, or somebody else approve that deployment. And we are talking here about master, but that master can be, of course, different customers. So you can have multiple deployments at once. So to show a little bit how that works, I have here my main template. This template covers all the stages that I want to deploy to. So, for example, you see the dev stage. But the great thing about how this is built up is most of the time when we are deploying configuration to Azure Sentinel environment, those are the same. The only differences are maybe the subscription where the workspace is, the naming, the resource groups, and maybe which resources or configurations we do want and we don't want to have in our Azure Sentinel environment. And as you can see for this demo, we are making use of templates. And templates are a file where we can define all our steps. It doesn't matter if you need them or not, we can define them, and that's in this case here. So this is the actual list of all the steps. As you can see, it starts with enabling Azure Sentinel. It has things like deploy the logic apps, but it has also the import Azure Sentinel alert rule, or the hunting rule, or we have since last week, finally, Azure Sentinel data connectors, and so on and so on. So as you can see, we can just call that file, and instead of defining all those steps each time again and again, we say, okay, just call that file, and these are my parameters. And what you see goes here is there are actually the same properties, but some of them are here filled in. For example, my workspace name is here 01. My resource group name is 01. And I have for this environment the settings file, the hunting files, but I want also the playbooks, I want the data connectors, I want everything to be deployed. And I have an example here where we say, okay, well, this is production. I have a different workspace name, but I don't want to deploy any hunting rules, or I don't want to connect my connectors on that environment. And this way, the script is smart enough to say, okay, as you can see here, the conditions say, okay, you haven't provided that as an input. That means you don't want to configure that. And that way we can have a standardized environment to deploy.
Nice.
So how does it then look? Lots of talking then, but how does it look? Well, I have created some runs earlier to show you the options that we have. So what you see here is that this deployment is triggered from our development branch. And what you see here is that I have also in our main template. So, well, you have a condition. So if you want to deploy to a station, that means that the changes, that the branch that triggered this deployment needs to come from the release branch. And if you want to go to the production, you need to come from the master branch. Otherwise, you cannot even start that stage. And if you take a look, how that looks like is, so this is a start from development. You see that it did all the steps. It went and it enabled it, and it started implementing, deploying. Here it throws some errors. Here it imported our hunting rules, and so on and so on. But it skipped the other environments because the source of this trigger was not the right one. So this way we can automatically protect our environments.
Yeah. Nice.
And another example is, sorry?
No, I just wanted to say, you at the end we will post your link to your blog as well as a show note, because I saw that you have also released the code for these pipelines, etc., to the public. So if people are interested in building it themselves, they can, right? Definitely.
It is available on not this one, on this GitHub environment, please use it. Give feedback back, and hopefully we can update it and make it better and better. Nice.
Well, that's quite some emphasis on DevOps for a live stream about Azure Sentinel. But I think it's important to understand that when you're seriously implementing Azure Sentinel, you obviously want some kind of version control for your analytics rules. You want control on how you're going to make changes to those environments, especially when you have multiple of them. So making bulk changes is a piece of cake. I know from customers they want to make changes to automation tasks for detection rules. Normally you have to go through the interface rule by rule. It's a very difficult task, and you can make mistakes easily. So this way you're forcing people to go through through code change and also validate their changes beforehand. So that's really nice to see. it's also nice to see that Microsoft acknowledges AZ Sentinel, the module you started with a year ago, and they are mentioning it in training documentation and in their blog post as well. That probably makes you a bit proud as well, I can imagine. So before we move over to our next topic, I want to switch to Maurice. Maurice, how's everything going on your end? Are there maybe any questions for us?
Yes, there are a couple of questions, but first I want to mention that maybe people have missed the start of the live stream. The live stream, sorry. Also lightning fast. And they missed that maybe we have today a very nice giveaway, and you can send in questions using hashtag AskWortell on Twitter or here on the live stream in the live chat box. And at the end of the show, we will decide who is the winner of today's great prize, Microsoft Flight Simulator 2020. The first question that came in, Koos, is maybe for you. It's about the Ignite news you told about. It's from Xander Oortgiese. Are all those new features general available or in preview that you mentioned?
That's a good question. I must admit that sometimes the lines for me are a bit blurred when talking about new features, because a lot of these features were already in private preview. So I did spend some time with them before they were announced at Ignite. But all the things I talked about are available to everybody, but some of them, like the watchlist, for example, is officially still in preview. So it is a public preview then in this case, and no longer a private preview functionality. But the screenshots I showed with the new blades in the Azure Sentinel interface, those are available for everybody, but officially not everything is generally available. So we have to make the distinct between those things. And I know that the watch list is in preview, and I'm not very certain about the other things. I think I can safely say that Teams is general available, but the threat indicator management might be in preview as well. I think it's listed in the interface, by the way, for the watch list in the DDS. So I hope this answers his question.
I believe so, yes. Okay, and then another question is from IJsblokje. He asks, I'm currently working on an Azure Sentinel DevOps with PowerShell and Sentinel API. What is the biggest reason to use PowerShell module over the official API? So I think that's for Pouyan.
I'd like to hand that question over to Pouyan, I guess. I think he's the best person to answer that.
Yeah. Well, actually, the big difference is that because even in the PowerShell module, we are still using the APIs, right? But what we are trying to do is to handle the error handling, and that's the big. Most of the time, you have lots of work to handle those kind of issues. So the reason both are fine. But what we try to achieve in the PowerShell is to handle those errors, to come up with some smart stuff to make it even better. For example, playbooks is something that would mean normally you will do a double API call, and now with Azure Sentinel you just say, give me a new alert with a playbook, and it recalculates that for you and creates also couples the data, the playbook. Sorry.
Yeah. Was that it, boys? Any other questions regarding this topic, maybe?
Okay. Well, there was another. There was a Ben Gellens. He says, "Well, I love the tests. Maybe a good idea to have schema files to help authoring. Keeps you helping from making those typos." Wow. So the people are.
He's the grote baas, so.
Yes. Yes. Okay, yeah, and there was another question from John, 3620. Thank you for the demo. Can you use Azure DevOps to deploy multiple Sentinel production environments?
Yes, that's possible. Pouyan also mentioned that you can have multiple. Well, there are different approaches to that. You can have multiple multiple repositories with a main branch, or deploy multiple instances from one main branch. Am I right, Pouyan?
Yeah, so we can of course deploy into multiple production environments. One big important is that where they are and that you have your service connections ready so that you can access those environments. I think.
Right. Well, that's it for the questions for now.
Okay, thank you, Maurice. So now let's head over to our second subject for tonight, and that's the honeypots. So I'd like to discuss this with Lars and Gijs tonight. Hey guys, maybe Lars, let me start with you. Can you explain me what a honeypot is?
Yeah, sure. What we actually mean when we talk about honeypots is you're simulating or leaving a vulnerability exposed to attract hackers. So yeah, you have different reasons why you could want to use one. You can share data, and yeah. So the main reason is it's a computer system where you expose a vulnerability or you simulate it.
Yeah, you lure in the hackers, if you will, to make sure that they stick to the honeypot and they get noticed.
Exactly.
Yeah. So I know you've been working on honeypots for us internally, and if I'm not mistaken, that's mostly from threat intelligence perspective.
Yes, exactly.
Can you explain to me what kind of honeypots you deployed and what you're doing with them?
Yeah, sure. So you have two different honeypots that you can actually talk about. The first one is to distract attackers from your production servers. And the second one, like you mentioned, is to gather cyber threat intelligence. So what we use it for, and what I've been working on for the past 8 months, is we gather the threat intelligence from the honeypots. We share this, and we use it to get our service of the managed detection and response to a higher level.
Nice. And how are you actually sharing the intelligence? Because I assume you have a honeypot with a public IP address, so you get a lot of requests from everywhere over the world. People just trying to exploit your machine. They think it's an actual machine with an exploit. But what happens next? They obviously do not succeed, but then you have you have some intelligence like IP address, etc. What do you do with that?
Yeah, exactly. So what happens when attackers exploit the honeypot? It gets locked. I will show you something about it in a demo I will be giving later. But
Okay, nice.
so like you said, like you mentioned, the IP address that's being used, we lock that. We forward that to Log Analytics workspace, and from there we use alert rules to share that to MISP. And what MISP is, it's a malware information sharing platform. It's an open source service, what you can call it, where multiple communities can connect and share threat intel. For example, you can define your objects like IP addresses, indicators of compromise, payloads that are being sent when hackers are trying to exploit the honeypot, and you can publish your own feed, or you can subscribe to the feed of someone else. For example, if you want to use threat intelligence of another community.
Yeah, so in this case, you mentioned the agent. So in this case, you have the honeypot in our own environment. So it actually runs the monitoring agent from Microsoft. So is it just a virtual machine then with just some software which emulates some kind of server or something?
Yeah, I think the easiest way to get started on that is if we actually start doing the demo right now. So I can give a bit of an overview of the Honeynet architecture that we use.
Yeah, sure. Go ahead.
So we have a base layer of Azure. On this, we have multiple things installed. The first one that I'm going into is the Ubuntu virtual machine. So in this virtual machine, this is basically where the honeypots are being executed on. We install Docker. In Docker, we run the honeypots that we use, and with the log analytics agent from Azure, we can actually ingest custom logs into Azure, and from Azure we can forward the data to MISP. We can forward it to Grafana to actually visualize our threat intel data with KQL, the Kusa query language. And we can also use Azure Sentinel to subscribe to a threat intel feed also from MISP. So you can actually publish your own threat intel feed, and you can subscribe to it to what we use for the managed detection and response service that we deliver to our customers. We can actually use our own threat intelligence to build use cases on that, for example. So I think the best is if I start going over the honeypots that we use, because I think that's the most interesting part. Yeah. So right now we have.
I'm sorry to interrupt. I just wanted to ask. So you have several different honeypots already realized. What kinds of honeypots are they?
Right now we have a honeypot for the Citrix mesh exploit or vulnerability, as you can call it. So this one is probably the most well known because it was a huge deal in December 2019 when it was first released. That there was a vulnerability in Citrix, and the big problem with that was that like a month later, an exploit was released, the first publicly released exploit, and the problem was that there wasn't a patch available. So this had a pretty big impact on a lot of servers in the Netherlands, but mostly in the United States. For example,
I'm not sure if you recall, Lars, if you can recall that in the news there was even a specific word for that, because a lot of people were used to working from home, logging into the Citrix environment, and because Citrix wasn't releasing an update, they shut down those servers, and people had to go to the office instead of working remotely, and that caused a lot of traffic jams, which is also already hard to imagine now in the COVID situation we're in. But the news outlets actually called that Citrix files, which are Citrix traffic jams.
Okay.
Just a fun fact on the side.
Yeah. So also a fun fact is that a lot of government agencies use Citrix to work remotely. And at the time, I was doing my internship for a government agency.
Really?
So when I was in the last 2 weeks of my internship and I had to do everything to my report, I had to actually go to office. I couldn't work from home. So that was also for me a big deal breaker.
So reminding yourself to this exploit is causing you headaches as well.
Yeah, you could say that. Yeah, still having nightmares from that. But
nice.
but the other honeypot that we use is from the SQL reporting services toolbox. So right now, both of those honeypots are running within Docker on the Ubuntu VM. But for now, for the demo, I'm running them locally. So I'll show you what that looks like in the terminal. So here I basically use the command to run the honeypot. So you can see here it's listening on port 8080 and 8443. The other honeypot is listening on port 80 and 443. They're both web servers, so I also have them right here. So this is the Citrix login page that actually hackers get to see when they enter the public IP address of the honeypot. Also, if I enter my credentials here, it also gets logged. The second honeypot we use is a fake page of the SQL reporting services toolbox. So what I'm going to do now, I'm gonna show you guys how to exploit these honeypots. So we'll start off with the Citrix log. We'll start with generating some logs for the Citrix honeypot. So what I have here is the first publicly released exploit of the Citrix mesh. This is the common vulnerability exposure number that was given to it. And right now I'm going to execute it on the honeypot here. So what we can see here is I'm using a bash to execute the script. I'm using the target IP address of the Citrix honeypot. You can remember that I just said port 8443 on that. And this is the command that we are using. So right now when I hit enter, it should do the exploit, and we can actually check for that, because if I use the cat command and I try to access the logs, it will actually see that we just generated an exploit log. So yeah, that's what we can see here. We can also see that check what kind of request we did to the honeypot. So we requested the username -a. If I go to a log analytics workspace where we gather all the logs, you can actually see here that that it's possible to see that I use this command. So we can actually log the IP address here. This is from the Citrix honeypot. This is my IP address. But we can actually see what they are trying to do on the honeypot. Same goes for the other honeypot, the SQL reporting service. So what you have to do to exploit this one is you make a post request. So if I make a post request now, we can actually see what kind of payload is being generated. So let's clear this out. Right now, I'm going to the directory where the log is saved, and we can actually see that that gives a postman token with it. We can see the source IP, so of the honeypot, and the IP I use. Yeah, it's locally hosted, so that's why it's the same. And we can actually see here that we get that data also in log analytics. And a nice thing about using log analytics is that we can also visualize the data. But first, I'm going to give a small intro to Gijs because he will go on to the story later. But right here in Visual Studio Code, we are also collecting the SSH field attempts. So since it's let me check where the image is. Yeah. So since it's an Ubuntu VM, rsyslog is installed by default. So that means that a lot of log events are actually captured by default. So this is what we get out of that. And you can see it's a lot of rubbish that we don't want to use. So what we can do is we can change the config of the rsyslog, and we're filtering the messages and generating a new kind of log. This log that we use is a lot better to is a lot easier to read for us, because we can actually see a failed password for the root user from specific IP addresses and the port they are trying to use. And Gijs will go on about this later to show what kind of cool things we can do with all of this data, because it's really a lot of data that's coming in. So going on to visualizing our data, I actually built a Grafana dashboard where we can actually visualize all the threat intel that we use. So I'm gonna give you guys a minute to take in what you can see on the screen, and yeah, Koos, maybe you can ask some questions what you would like to know about this.
Yeah, first of all, Lars, Grafana, is it a free application I can just enroll?
Yeah, absolutely. The easiest way probably to start a Grafana instance right now is just pull the Grafana image from Docker, and you can get it running almost instantly.
Cool.
And the nice thing about Grafana is that you can use a lot of different data sources. So for now, we use the Azure Monitor data source to query Azure data, but you can also use Elasticsearch or InfluxDB or Prometheus, all those kind of things.
Yeah. Before we continue, I saw a remark from one of my colleagues on the back here in the chat we have internally. Gijs is planned to do a demo as well in a few minutes. But apparently Gijs does not have his screen shared properly with our software right now. So maybe that's something Gijs can take a closer look into. So that he can show us some insights behind these dashboards. So the nice thing is that Grafana just forwards the KQL query, right? So behind all of these tables and graphs is actually KQL data, right?
Yeah, I can show you right now. For example, this is a panel that shows the types of HTTP requests that are made to the honeypots. Because both the honeypots are web servers, I think I mentioned that. But we can go to edit and we can actually see the query that is behind this. And if I paste this into log analytics, it will show the same results. Only the nice thing about Grafana is that you can put all kinds of transformations on it. You can rename fields. You can make things larger, and you have all kinds of different cool visualizations that you can implement. So what this actually does, it filters out all of the objects that are generated by the honeypot, because since this is a web server, all these images and things are loaded. We just want to filter that out because it's not interesting for us to see. But if you scroll through the results, then we can actually see what kind of other HTTP requests attackers are trying to get. So that's pretty interesting.
Yeah, and especially with the Citrix exploit, people were actually be able, through using a specific URL format, to run bash commands on the Citrix device. So it would be quite interesting to see what the people are actually trying to accomplish from that device.
Yeah, exactly.
And I saw a long list to the right. Can you show us what you're visualizing there? I saw a bunch of usernames, I guess.
Oh, yeah, sure. A bunch of usernames. I think that's on the.
Oh, no, I'm sorry. That was the different view. I'm
panel.
sorry. On the left here, you have the time slots.
Yeah, exactly. So what this query does, well, I'll go into the visualization first. So what we can see here is we have different time slots, and we can actually see the percentage of activity that's being generated in each time slot. So the query behind this is actually pretty interesting. Because first we create a couple of data tables, and we use that to calculate how much traffic is coming into each time slot. So we can also use this in our managed detection and response service as we use it already, because we're actually doing 24/7 monitoring, and this graph actually shows why you need that, because you can see that starting from 5 o'clock that traffic is going up, and that's after business hours. So that's really why you want that 24/7 on screen time, eyes on screen time.
Yeah, good point. Yeah.
And here we just have some interaction and SSH attempt. What do you call it? Basically, there are counts per time slot, so you can just see the activity of the past week. The second visualization that I have for you guys, or the second dashboard, is actually an attack map, and this is especially cool because you can actually see where all the traffic is coming from. So on the left we have a big counter table for that. You can see that actually 366,000 SSH login attempts are being done from China. 82,000 from the United States, so on. So since we left SSH open, it's well known that you shouldn't actually do that, because well, this is why a lot of traffic is coming in, and you see that you see right away that the majority of the usernames that are being used by attackers is a root user, because it's a Linux VM. So here we actually have a whole list of usernames that people try to use to log into the Honeypot through SSH. Of course, they're all wrong, but they can try.
Yeah, of course. They're probably just running scripts and scanning IP ranges, but still, if they have success on one IP, they might try to get in and try additional steps.
Yeah, exactly. And what's also cool is we can actually show the query that I used, because last night at I think 4 a.m. I put this in production. So I really wanted to show this this to you guys, because yeah, it's a big piece of eye candy. But
Yeah,
what we actually see
those
is
are
we
not
have
regular working hours for us at Wortell, right?
no, no.
But sometimes
But
you just want to complete something. Yeah, I understand.
yeah, sometimes you're onto something and then you just gotta go with it. But what we actually do here is we make a big data table where we have the country ISO codes with the name behind it, and the latitude and longitude. And what we can do with this big query, we're actually getting SSH logs, and we're adding country codes to them, the ISO codes. So this makes it possible to join the country code data on this data table, and it makes it possible for us to display the latitude and longitude of those country codes. And Gijs is going to explain more about that, because he actually made it possible to get that extra data into the logs, because as you can see here, it's pretty difficult. Yeah, here you see what we saw in the other panel, where you see a big count of the country codes. But actually, what we want to do is get the full data of those logs. And you can see here, this is the raw data that's coming in, because in custom logs you cannot say this has a certain value. So you can what we do is we use a script, a Python script, to get this into our log data, so we can map it. And Gijs is going to tell more about that.
Yeah, maybe we can switch over to Gijs right away. So Gijs, please join in. I understand you've been quite busy providing the additional data needed to fill the world map. Maybe you can tell something about that, and how it all worked out.
Yeah, so that is indeed a little project that Lars and I started together. As he said before, the honeypots, they log. Well, one of the things they log is the IP address. That one is, for us in this situation, the most interesting, because even though the honeypot doesn't see like the geographical location where a connection is being made from, with that IP address you can still get that information, because it is available online. There's a lot of databases that connect these IP address to geographical locations. And for us, we used the geospatial services provided by Azure Maps to get this. They have an API that you can make requests to by sending in an IP address, and they will respond with the ISO code, which is what we needed for the world map.
Okay, nice.
Yeah, and it was a fun project. I can show you quickly what that process looks like, if I can confirm that I can see my screen. Yeah, I'll show you what it looks like. Is it visible now? Because I minimized the screen.
Yeah, these fonts are quite small, but I'm not sure what you want to demonstrate.
Okay, well, first I'll quickly show like the structure. The script is right here. We have currently two. I prepared two sample logs that we can use to enrich it. This is one of them. Each line represents a single connection, and then we also have this one, which is not formatted correctly. I can see. anyhow, what it's going to do is it's going to read out this existing log file. So it has to have already an existing log file from the Honeypot. And then it's going to use these geospatial services from Azure Maps to find out what the geographic location is for each IP address. And then it will write it out to a new file, put it in the corresponding folders, and it will also locally cache right now the data that it has found. So if if you find an IP address that you have found before, which is going to happen a lot because usually when people visit these sites, they don't visit and leave right away. They tend to do multiple things, and it would be a waste to use the Azure Maps API for each thing someone does. That's why as soon as a new IP address has been looked up and has been added, has been enriched with an ISO code, we store it locally so we don't have to look it up again. So very simple. I'm going to well basically see what it will look like eventually. We have seen the log as it was before. Then
is it possible, guys, for you to scroll a little bit with your zoom a little bit in your PowerShell window?
I'm not sure.
If you
Usually I
control
use
scroll, you zoom.
is that I usually use Ubuntu. Right now it is not working. I have to say I have to say though that the terminal itself isn't that interesting. I just need to run it, but I will
Okay,
tell you what it says regardless.
no problem.
So what I do, I just call the script itself. It is a Python script. Okay, it will tell me that it is creating a container file because it was still empty. That's what was here. It created it. And it also created both the output files. That is because it's a fresh instance. It was clear, and that's why it had to create the file still. So I will show you. This is what it looks like now. Is that at all visible? Because you said it was a bit small.
Yeah, it is. It is quite small, but that's okay.
All right, I can see if I can.
It's not something we can do about it right now. Maybe, yeah, if you want to show yeah, you can zoom in on the file maybe, but
Yeah, it doesn't seem to work the way I expect it to do.
no.
What we're seeing though is the original files on the right. It has the IP address somewhere in the middle of the sentence. That's basically the only constraint that is needed. There needs to be an IP address in it. So that means that it would work on a lot of different files. And all it does is when it has found an IP address like it, it will use the geospatial services from Azure Maps. It will look up to what country that IP address belongs, and it basically just adds it behind it. And then it writes it to a new file, so you don't overwrite the old existing file. And now you
Okay.
have extra data. So now for each connection that is being made to the honeypots, we don't only know the time, the date, the IP address, and what they were trying to do. We now also know the country where it all originated from. And that is actually very useful when you want to fill a geographical map like the way we did.
Yeah, nice.
Yeah.
So, are there any? Yeah, I'm sorry.
Yeah, no. I was just rounding up. That's basically what the script does right now. It could do more technically. There's a lot more information available that belongs to IP addresses, but this is what we started with for our project.
Yeah, nice. And what kind of improvements do you have on the roadmap for these honeypots and these kinds of scripts?
Well, there's actually for this specific script, there's a lot I would still like to do. One thing was, well, right now we only have ISO codes. It's because we are using Azure Sentinel, which is in our situation ideal. Although they cannot yet give longitude and latitude, that is something that I would like to add to it. But like I said, there is a lot more information available. You can check whether an IP address belongs to a VPN or if it is already known uh, um, as a malicious IP address, stuff like that. We could also look up and add to it. This is what we started with, and it can expand. Something else that there's a couple of other things that to this specific script that we would like to change, and that's the way we're caching it right now. Like I said, I'm storing the IP address with the matching ISO codes. As of now, they are stored indefinitely, which is probably like that information becomes outdated at some point. You want to have like a time that it is valid on it, something like 2 weeks, and then you want to say, okay, we clear it out for now, and if it comes back, we'll just write it back down. So there are still a couple of things we can do to improve it, and we plan to do so. But it's not the only thing we're doing right now.
Yeah, I would like to add something to that answer, because not only are we developing the script where we enrich our log data, we are also at the moment we're busy transferring to a Kubernetes cluster where we can actually scale our whole Honey network. So for that, we have a couple of new challenges coming up, because right now an Ubuntu virtual machine has if you deploy it in Azure, it has a log analytics agent installed automatically, or at least when you're creating the virtual machine, you can add an option to enable monitoring on that. But when we're transferring to Kubernetes, we are going to need a new solutions for our for the way we collect and forward our logs. So we're probably going with logstash on that one. So there's a lot of cool things that we're planning to do. Like
because once it's running on a Kubernetes cluster, it's more scalable, it's more highly available, and you have also probably less work maintaining and updating and keeping that machine virtual machine running.
Yeah, that's a goal. Yeah, we're also we're also looking at expanding the Honey network with. Like right now, we're collecting the SSH logs. We're only getting an IP address from it, but we're also doing some research about simulating a file system on the Honeypot. So instead of the hacker getting the message login failed, they're getting a message saying login successful, and then we want to see what they're trying to do on that machine.
Nice. Well, awesome work, guys. If people want to try this for themselves, do you provide some documentation and maybe templates for these kinds of environments and honeypots?
Yeah, sure. In the description of the video, there's documentation to be found about the SQL reporting services Honeypot, and also both GitHub pages of the Honeypots are available in the description. So if you're trying to mess around a little bit, you can actually clone the GitHub repository and start running it locally, like right now, if you want to.
Nice. Well, again, awesome work, guys, and I'm looking forward to what kind of new features you both come up with in the next couple of months.
Thanks, Koos.
Thank you.
Okay, so let's check up with Maurice. Maurice, are there some new questions for us, maybe?
Yes, there are a lot of nice mentionings coming on in the social medias. People are liking the stream, and there's a question from Xander Oortgiesen. Is running honeypots on Azure supported? What is Microsoft's point of view regarding to this?
Well, I am not sure if we haven't specifically asked Microsoft if we could get a confirmation for running a machine on Azure to do a specific purpose, but I don't see why we should mention that or what we're actually doing wrong, because we're just running in this case an Ubuntu VM with an open port. I think a lot of companies have VMs running with open ports. And the only thing we're actually doing is saving the logs and creating threat intelligence from those activities. So we're just paying for the virtual machine, we're paying for the traffic that goes into the machine, and if some hacker for some reason knows how to bring that machine down, it's our responsibility, it's our virtual machine. So I don't know why this would be an issue, actually, to be honest.
Yeah, I agree. Yeah. And there's another question from Jack Spearing. What will honeypots look like in 5 years? What are developments like artificial intelligence, etc.?
Lars, guys, maybe you can shed some light on that.
What it will look like in 5 years? Well, I think it should have in 5 years. It should have vulnerabilities that are relevant at that time. Like right now, we have a lot of different vulnerabilities that you can use for honeypots. But in 5 years, there could be the security could be a lot better, and maybe there could be way more advanced honeypots than the ones that we have right now. And probably you can in 5 years with artificial intelligence, you can probably get a lot more data out of those honeypots.
Right.
Of course,
Cool.
more cool dashboards.
Yeah. Well, maybe that's a good lead to the next question from IJsblokje. He asks, well, how do you react to the honeypot data? Do you view the dashboard or also automatically block connections, for example?
Yeah, that is something like. Oh, I'm sorry, Lars, you can respond as well. You go first.
Yeah, sure. So, like I said, we use MISP to forward our we use log analytics to forward our data to MISP, and in MISP we actually subscribe to our own MISP threat intel feed, so we can use the threat intelligence from our own threat intelligence feed and build use cases around that for Azure Sentinel. So, for example, if I exploit the honeypot with my current IP address, an alert will go through MISP that will be sent back to Azure Sentinel, and maybe we can make our own block list. And the moment that we see a sign in from one of those IPs, that we generate an alert in our Vidara incident management system.
Yeah, and I'd like to add to that, if you indeed create a use case in Sentinel in which you aggregate data from maybe your firewalls, or like Lars mentioned, successful or maybe unsuccessful login attempts from Azure Active Directory, for instance, you can match and then join those IP addresses to the data from the threat intelligence feed, in this case MISP, for instance, so that you know that you want to actually block out those connections. And then Sentinel also is a SOAR. SOAR stands for Security, Orchestration, Automation, and Response. So you can build automated responses on your use cases. For instance, a logic app which triggers on that use case, and then through an API call, or it can even automatically make a firewall change to make sure that an IP address gets blocked, or even if you want to send out an email to the management team for your firewalls, or you can do it manually, of course, as well. But you can even fully automate those kinds of steps if you want.
Okay. Well, there's another question also from IJsblokje. Do you guys have honeypots deployed at multiple cloud locations? If so, if you have seen any correlation in information between the honeypots?
Yeah, right now it's funny that you mentioned that, because right now we are working on transferring to the Kubernetes cluster, and when we're deploying one cluster of honeypots, we're actually planning to deploying multiple clusters, and then putting that cluster in the different regions. So for now, we are in West Europe, but we were also curious to see what happens when we put it in United States, and we are also planning to correlate the data like you ask.
Cool.
Yeah.
Nice.
And obviously, once that honeypot is running in a container or on a Kubernetes cluster, and we build a Kubernetes deployment for it, it should be very easy to deploy it on a Google Cloud or AWS as well, if you would specifically like that to do so.
Yeah, sure. Yeah, we're also working on a YAML file where we are actually specifying what the deployment should look like. So you could apply to any Kubernetes cluster. Doesn't matter if you're running it in AWS or in Google Cloud or Azure, or even locally.
Yeah.
Okay. We have another question from Jack Spearing. How do you determine what CVE you are going to use or gonna fake?
I don't know what the consideration is. Maybe you want to see what you want to go is you want to attract the most possible attention to the honeypot. So you're looking at a vulnerability that is used quite often. So you can also generate a lot of data. That's probably the consideration that you're making when you're choosing a CVE for a honeypot.
Okay, nice. There was another question that was a while ago. I skipped it. Sorry, Gianni Castaldi. Can we use AZ Sentinel in the near future for threat intelligence? I think he means the AZ Sentinel PowerShell module, of course.
Yeah, and I think he means configuring threat intelligence through the PowerShell module.
The rules, importing those rules. If I would suggest create a feature because it's doable because we just need to import those to the Graph API and they will automatically be pulled to the Sentinel environment. Yeah, please make a feature request on GitHub.
Or even better, Pouyan, let him fork the registry and build the feature himself, and through a pull request push it back to you.
That would be great. But yeah, I think because there are multiple ways to achieve it, it's good to have a short conversation about this on GitHub separately.
Yeah, of course. Yeah, just write an issue on Pouyan's, or no, it's on the AZ Sentinel repository, and that conversation will start. Of course.
Yeah.
There's another question from SanTX552. Do you yet deliberately allowed Chinese hackers to take control of a honeypot to analyze what Chinese hackers do?
Come again? I didn't understand the question. Do we allow Chinese hackers to take over the honeypots?
Yeah, well, I think that's just, for instance, Chinese hackers, because you saw in the map there were a lot of them.
There were a lot, yeah.
I think the real question is, do you also analyze what hackers are using kind of attacks or...
Lars, I think you know most about that right now.
Yeah, the attacks that they are using, the honeypot is designed to log the exploitation of a certain vulnerability. So we can the data that we can see is we can see what kind of payload they're using to exploit the honeypot and what kind of code they will be trying to execute on the honeypot. That's what we can see, but we're not as far as correlating that data from China or yeah, things like that. We're not busy with that yet, but maybe we will.
Right. There's another question. How can you forward log analytics data to MISP?
Yeah, that's actually a pretty good question. That is something we are working on currently. The way we're doing that right now is when an alert from log analytics comes in, you can define an action group. So when a specific threshold for an alert is reached, a certain action that you can define yourself will take place. So in the case of what we're doing right now is we're using Azure Functions and webhooks that whenever an alert in log analytics occurs, it is the information that matches that alert is sent in a JSON payload by webhook to the function. Then the information from the alert is in the Azure function, and from there it can create a post request to gather all the information it got from the alert and send it to a MISP instance to generate the MISP feed like that. So basically, in short, from the log analytics alert, an Azure function is triggered containing the information from the alert, and that Azure function sends the data to MISP. That's how it how we intend to implement it.
Okay, cool, nice. Well, I think that's that wraps it up. I think there aren't any more questions anymore.
It's
No?
really great to see that we received such a large amount of questions tonight. It's good to know that people are actually watching and interested in the subject, and it also helps us think about things we might have not think about ourselves, and keep this live stream interactive. That's really good. So if there are no other questions anymore, then I think it's time to wrap up. 1.5 hours. I think that's a record for an Ask Wortell live stream as well. I hope we kept enjoying everybody until the end. Before we wrap up, I want to refer to a few resources. Microsoft recently announced a specific Learn module for Azure Sentinel, so we put the URL in the show notes as well for that. And if you're not new to Azure Sentinel, I think you can still learn a lot from the documentation the product team has gathered for you. They call it how to become an Azure Sentinel ninja. So they are also into ninjas, Pouyan. And that is, they keep together a quite comprehensive documentation with external links and guidelines, and they even update it quite regularly. So all those links are in the show notes. Also the Wortell's GitHub page as well, containing the Azure Sentinel source code. Also the link to Pouyan's blog we mentioned, with all the source material referenced, and where you can rebuild it for yourself, and the honeypots. So before I want to thank a few people, I want to announce the winner of tonight's giveaway. We had one particular user who sent us several different questions tonight, so that's why we think we can announce IJsblokje as the winner of the Flight Simulator 2020 coupon for PC or Xbox. So congratulations, IJsblokje. I'm not sure if you have reached out to us by Twitter, but if you did, please DM us or send us a message over there. And otherwise, I will put an email address in the show notes as well, but it's werken@wortell.nl. I assume, since you named yourself IJsblokje, that you're Dutch speaking. So I think werken@wortell.nl would be sufficient for you. So please send us an email or a private message on Twitter, and we'll make sure that coupon reaches you. So have fun with that. Okay, so now I would like to say a big thanks to all of you guys, Lars, Gijs, Pouyan, and also Maurice for joining us tonight, and everything you've done so far, and making the time in the evening to have this live stream with us. And also, I would like to mention big thanks to Jeroen Niesse, our colleague, who is working very hard at the back end right now. He's juggling with all the buttons to make sure everybody gets on screen at the right time. And he's actually making sure that all of our streams from our home go through his network, so he can broadcast this from his home. And I even understood that his girlfriend was allowed to use the internet tonight to make sure we had as less latency as we needed to. So also big thanks to her to make this possible. And thanks for watching, everybody, and see you next time. Bye-bye.
Bye.